Alright, so today this video is over logarithmic functions or logs, and it is 4.3. And there's a lot of things with logs that you'd have to use a calculator and all that other fun stuff, and we'll talk about that in a little bit, but most stuff we're going to be doing with nothing to do with the calculator. Okay? Or can be done without a calculator, let's put it that way. Okay, so we have a logarithm, and logs we learned in Algebra 2, so again this is a revamp for you, so hopefully a very quick lesson. Okay, so we have a function of a log, and logs are functions. We'll talk about the picture at the end. I did post these notes and the answers to these notes. However, we're just going to do the first 2 pages. The last 2 pages of those notes you're not going to need. I do give you the answers to those. You can look through them, but they're not actually in our curriculum because a lot of it has to do with calculators. So, then we have a function log of a base of some number, okay, is equal to y. Is equivalent means it's the same as an exponential function. Base b of y is equal to x. And one thing you have to be able to do is go from one form to the other. Okay, so these first 2 rows, these are just things that are, well, they're all true. Okay, and we're just wanting to rewrite them into different forms. So in this first row here, we want to rewrite these in exponential form. In other words, I want to find my base, I want to find my exponent, and I want to find the x value. So in this case, here's my base 4. 4, this is always going to be my exponent, squared is 16, which we know is true. Same thing here. 5 to the exponent negative 1 is 0.2. Okay, which is essentially, that's 2/10, which is a fifth. This is a fifth, and if you remember, negative exponent, so it does work, right? Alright, then we have base 8 to the 0 power is equal to 1. Okay, so a couple things. Okay, bases are positive. Okay, base can't be 1. Okay, and they are positive. X and B have to be positive. X and B have to be positive. Y can be negative. Okay, and then again here, 23 to the 0 power is 1, because anything to the 0 power is 1. Okay, so can we go the other direction with this? Base, this is my x value, right? So it's going to be log base 2 of 16 is equal to 4. Okay, base 27. So log base 27. Let's write it a little bit better. That's kind of big. Log base 27 of 3 is equal to 1/3. And then in this last one, my base is a fourth. So log base a fourth of 16 is equal to -2. Okay, so if we know those order of everything, we can actually find some solutions. When it says to evaluate, now these are logs that we can do by hand. Okay, it says evaluate this log. Log base 12 of 144 is going to equal some value. Well, if I change it to exponential form, 12 of x is equal to 144. Well, 12 of what exponent is 144? X would have to be 2. Okay, and these are numbers that you should be able to handle. Okay, now, what if it's a number you're not quite sure of, like 64 to some exponent is 8? Well, what you want to do is you want to change these into lower bases. And there's a couple different trains of thought. Okay, the ones we give you, you're going to be able to change a base pretty easily. Okay, 64 is technically 2 to the 6th power would equal, and 8 is 2 to the 3rd. We want to use same lowest base possible. And 2's are your lowest base. So this would be 2 to the 6x is equal to 2 cubed. Now, how does that help me solve? Well, if I have the same base, for these to be equal, your exponents have to be equal. 6x would equal 3. And so x would equal 3 over 6, or x is a half. And you can do some basic work with that. Okay, again, change to the lowest base. Now, I could have gone this with 8, but they're not always going to work that nice. Okay, case in point, 3 to the x power is equal to 1 over 27. Well, because I have a fraction, there's a good chance my x value is going to be x, or is a negative. So, in this case, 3 to the x power is equal to 27 is 3 cubed. So if that's 3 cubed, would that equal be 3 to the negative 3 because it's from the bottom. So x here has to be negative 3. Alright, now there are a couple special bases or special logarithms. You have what's known as the common logarithm, which is base 10. So, logarithm of base 10 is called a common log and is normally written without the number. Notice no number here. And then you have the natural logarithm, which is base e. Okay, so this is base e, and we talked about the number e in the last section. Now, if I have the common log, doesn't write the base, that's just assumed base 10. Then we write natural log as ln. This is natural log, which is base e. Alright, now how does that help? Well, how do I evaluate? Well, if I'm trying to find that answer, this is base 10, so it's 10 till some exponent is equal to 100. Well, don't we know that that has to be 2? 10 squared is 100. Okay, same thing with this. 10 to some exponent is equal to 0.0001. Well, 0001 is the same as 1 over tenths, hundredths, thousandths, 10 thousandths, which would be 10 to the negative 5, which is x is negative 5. Okay. Now when we evaluate, and we can go back up here, more than likely in your homework I'd have to look at it again, but you may just have to put the value when you evaluate, not the x. Okay. Now, how do I deal with this? Well, this is base e. So it's going to be e to some exponent is equal to e to the negative third. Well, your answer has to be negative 3. And along with this one, e to some exponent is equal to e to the 10th, which would be, well, it has to be 10. Okay, so those are quick things we can deal with. And there's some special rules we can deal with that. Okay, so the other page of these notes that we want to go through, this section we're not going to do just because you can just put these in a calculator. Okay, if it's log, it's base 10, natural log is base e. Most regular calculators have logs in it. Okay, your phones have a log in it. All you gotta do is turn it sideways. And a lot of them, you may have to push the 200 first and then hit common log. Okay, and some of them you might have to do the common log, then 200 equals 200. You have to just kind of fiddle around with your calculator. They all work a little different. But what we want to discuss is your basic properties of logs. Okay, so log to any base of 1 is always 0, because base with an exponent 0 is always 1. Okay, any log base of whatever base number, and these two numbers are the same, is always equal to 1. Okay. If I have log base b of b to some x value, these numbers are the same. The two b's are the same. Your answer will always be the exponent. And same thing here. If I have a base b with a log as an exponent, but they have the same base, the answer will be that x value. Okay, so this kind of goes, these are all ones we can do calculated because of these basic rules up here. So log base 19 of 19, if these two numbers are the same, okay, that falls in here. These two numbers are the same, answer is 1. Well, what about 20? Well, isn't this base 10? So the answer is 1. Natural log of e, well, because that's base e, those match up, the answer is 1. Okay, well, log base 273 of 1, well, that falls into this category. As long as this big number is 1, the answer is 0. Log base 1/8 of 1, well, again, if that number is 1, the answer is 0. Okay. Log base 30 of 30 to the 10th power, well, if those numbers are matched up, the answer is the exponent. Along with this one, you can use that same rule here. Exponent's the same as 1, right? Here, this is base e of e to the negative 12, which means the answer is negative 12. 26, 10 to the log. Now remember, that base right there is a 10, so my answer is 14. And same thing here, if these two numbers are matched up, the answer is 5. So all things you can do without a calculator. Okay. Now, if I gave you something like this, log of negative 5 of 15, that is not possible. That number can be a negative. Okay. Log of negative 100, also not possible. Because this number can't be a negative and this number can't be a negative. Okay. Now, the last thing we want to talk about is a quick thing on transformations. Now, this happens to be a log base 2 of x. Okay. Now, I can't actually graph this, but if I change it into exponential, 2 to the y exponent is equal to x, I can actually graph this using the exponential form. Okay. So, the way we do it is do it a little backwards, because look what the exponent is. Exponent's y. So what we do is pick y values, plug it in. So here's what I've done. I've picked all these first. And then we're going to find the x. So when I plug 0 in for y, that's 2 to the 0 power, which is 1. Plug 1 in for y, that's 2 to the first, 2 to the second, 2 to the third, 2 to the negative 1, 1/2, 2 to the negative 2, 1/4, and 2 to the negative 3, 1/8. So we have the following graphs. 1, 0, 2, 1, 4, 2, 8, 3 would be way out here. Whoops. Shoot a monkey. This would be 2, 1. Sorry. This would be 4, 2 here. And then 8, 3 would be here. Okay? And then we'd have 1/2, negative 1. Gotta look at these graphs carefully. They do that to you once in a while. Negative 2. Negative 3. So you end up having something that looks like this. Okay. Now, what's different about this compared to exponential functions? This is your parent here, your parent function log, and you don't have a horizontal asymptote. You're going to have a vertical asymptote at x is equal to 0. Okay. So because it's getting closer and closer to this value. Okay. Now, so this is your parent function. So this is parent of log base 2. They're all going to change a little bit, okay, depending on what the base is. Okay, because if this was base 3, this would be a 1, this would be a 3, this would be a 9, that would be a 27, and so forth. Okay, now, transformations off of logs. Here's your A, your B, your C, and your D. Okay, in college form, this would be log bx minus c. Okay, but we're not going to go in depth with these. You're just going to have to, if we were to give you this graph, Could you move it? Could you transform it? Okay. Well, if I give you log base 2, and that would be this graph, that's its parent function, x minus 2 minus 4. Well, wouldn't that be a right 2 and down 4? Now be careful with your graphs because I screwed it up. Make sure you count. These are by 1s and these are by 2s. Okay, so right 2 wouldn't, this graph, every point would go right 2, so it would be 1, 2, 1, 2, 1, 2, okay, and then we'd go down 4. So down 4, 1, 2, 4, 2, 4, 2, 4. Let's see here. 2, 4. And you'd end up with something that looks like this. And of course the right 2 would move the horizontal 2 places. Okay, or the vertical isotopes horizontally 2 places. Okay, so if you were given a graph, be able to find its transformations pretty quick, and if they give you those, that's basically all you have to do with it. Okay, so the other 2 pages of notes, like I said, not going to be required for you on your homeworks or your quizzes. These are the main things we need you to be able to take forward to the logarithms as we go into the properties of logs on the next couple of units. Okay, good luck and hope you're doing well, and hope give me come and see office hours. Remember, office hours are Monday, Wednesday, Fridays, 12:30 to 1:45. It's on Zoom. You will need that password if you don't use the link. The password has also been sent to you. Please don't share it with anybody else. Thank you.